The Celtic connection. Why the Irish are more Spanish than you think. In 2015, a team from Trinity College Dublin published the results of ancient DNA analysis on human remains from Ireland that fundamentally changed how scientists understand the origins of the Irish people. The findings confirmed something that most historians had dismissed as medieval mythology and revealed a genetic connection between Ireland and the Iberian Peninsula that predates recorded history by thousands of years. The mythology in question is preserved in a text called the Labor Gabála Érenn, the Book of Invasions, a medieval Irish manuscript that attempts to record the origins of the Irish people through a sequence of legendary invasions. The final and most important of these invasions, according to the text, was led by the descendants of a king called Milesius of Spain. His sons, the Milesians, sailed from the Iberian Peninsula, defeated the supernatural inhabitants of Ireland, and became the ancestors of the Irish people. The Book of Invasions was compiled in its surviving form around the 12th century AD, but it draws on oral traditions considerably older. For centuries, this story was treated by historians as pure mythology, a folkloristic explanation for origins with no more historical value than any other origin myth. The Milesian legend was charming but irrelevant to the actual genetic and archaeological question of where the Irish people came from. The DNA told a different story. Not in the literal sense that a king named Milesius sailed from Spain with his sons, but in the deeper genetic sense that the story was trying to express, that the ancestors of the Irish people really did come, in significant part, from the Iberian Peninsula. The genetic record and the ancient myth turned out to be pointing toward the same truth, just one with a precision and a time frame that the mythmakers of medieval Ireland could not have imagined. The 2015 Trinity College Dublin study was published in the Proceedings of the National Academy of Sciences and represented the first comprehensive ancient genomic study of Irish prehistoric individuals. The lead researcher was Dan Bradley, a professor of population genetics, and the work combined analysis of the Neolithic Ballinahattie woman with the Bronze Age Rathlin Island men. The two datasets together allowed researchers to identify the sequence of genetic changes that produced the modern Irish genetic profile, a sequence that placed the Iberian connection not at the periphery of Irish origins, but at its foundation. In 1999, archaeologists excavating a Neolithic monument near Belfast in Northern Ireland recovered the skeletal remains of a woman who had died approximately 5,200 years ago. The site was called Ballinahattie, and the woman, known since simply as the Ballinahattie woman, became one of the most analysed ancient individuals in Irish archaeological history. She was buried inside a megalithic passage tomb during the Neolithic period, the era of stone monuments and early farming that produced the Great Passage tombs of Ireland, including the famous site at Newgrange. The preservation of her bones was sufficient for both skeletal analysis and, eventually, ancient DNA extraction. The DNA results from the Ballinahattie woman, published in 2015, were striking. Her genetic profile was not that of someone whose ancestry pointed toward northern or central Europe. It was Mediterranean. Specifically, her closest genetic relatives among modern populations were people from the island of Sardinia and from the Iberian Peninsula, modern Spain and Portugal. She shared the genetic profile of the ancient Anatolian farmers, whose descendants had spread westward along the Mediterranean coast and up the Atlantic seaboard of Europe from roughly 7,000 years ago onward. She had brown eyes and dark hair, a physical appearance completely at odds with the popular image of the ancient Irish as a fair-skinned, red-haired people that emerges from later Celtic traditions. The Ballinahattie woman was not, of course, Spanish in any modern sense. She was a Neolithic farmer whose ancestors had made a long journey from the ancient Near East through the Mediterranean and along the Atlantic coast, eventually reaching Ireland. But she demonstrated, with great precision, that the first farmers of Ireland arrived with genetics that pointed toward the southwestern corner of Europe. The connection between Ireland and the Iberian Peninsula was not a medieval invention. It was written into the oldest agricultural genomes on the island. The megalithic tradition that the Ballinahatti woman's people built is extraordinary in scope. The Newgrange Passage tomb in County Meath, constructed around 3200 BC, making it older than Stonehenge and the pyramids of Egypt, required the organized labor of hundreds of people over many years. The astronomical precision of its alignment, which causes the rising sun of the winter solstice to illuminate the inner chamber through a precisely engineered roof box, indicates sophisticated knowledge of solar movement maintained across generations. It was built by people whose closest genetic relatives lived in Sardinia and Spain. The Ballinahatti woman's world was not the world that produced modern Irish genetic identity. Between her time and the present, two more major genetic transformations reshaped the population of Ireland. The first of these came with the Bronze Age.
Around 4,500 years ago, the same period that saw the Bell-Beaker cultural complex spread across much of Western Europe, new people arrived in Ireland whose genetic profiles were strikingly different from the Neolithic farming population that preceded them. The evidence came from a 2015 study of 3 male skeletons recovered from Rathlin Island, a small island off the northern coast of Ireland. The 3 men had died around 2000 BC, placing them in the early Bronze Age, and their DNA showed a profile that combined 2 distinct components. One component was related to the existing Neolithic farmer population of Ireland, and, by extension, to the Iberian populations that the Ballinahatti woman's ancestry pointed toward. The other component was steppe ancestry, the genetic signature of the Yamnaya and related pastoralist populations who had expanded westward from the grasslands of the Eurasian steppe during the Bronze Age. This combination, Neolithic Iberian-derived farmer ancestry plus incoming steppe ancestry, is recognizably the genetic foundation of the modern Irish and broader Celtic population of the British Isles. The Rathlin Island men also carried 2 genetic variants of particular significance. They showed the genetic variant associated with the ability to digest milk as adults, lactase persistence, which was strongly selected for in pastoral Bronze Age cultures. And they carried a version of the HERC2 gene associated with blue eye color, along with variants associated with lighter skin pigmentation than the earlier Neolithic population. The physical appearance of Bronze Age Ireland was shifting toward the fair-skinned, light-eyed phenotype more commonly associated with Celtic peoples today. The metalworking technologies that appeared in Ireland during this Bronze Age transition, copper and bronze working, show strong technical parallels with contemporary developments in northwestern Iberia, particularly the region of Galicia. The genetic and the archaeological evidence reinforce each other. The Bronze Age connection between Ireland and the Iberian Peninsula was real. The axe types, the copper sources, and the decorative mow. Among the most persistent folk traditions in Irish cultural history is the concept of the Black Irish, a term applied to Irish people who, unlike the stereotypical fair-skinned, red-haired Celt, have dark hair, dark eyes, and sometimes a slightly olive complexion. The most romantically appealing explanation for the Black Irish has always been the Spanish Armada theory. In 1588, King Philip II of Spain dispatched the famous Armada, a fleet of 130 ships intended to carry an invading army to England. The fleet was famously defeated by a combination of English naval tactics and catastrophic storms, and a significant number of ships were wrecked along the western Irish coast. According to the theory, survivors of these wrecks came ashore in Ireland, were sheltered by the local population, and eventually married into Irish families, passing their dark Iberian features to their descendants. It is a good story, The ancient DNA evidence shows it is largely wrong, or at least
Wildly insufficient as an explanation for the Black Irish phenotype. Modern genetic analysis of Irish populations shows that the elevated frequency of dark hair and eyes in certain Irish communities, particularly along the western coast, correlates with patterns of ancestry that predate 1588 by several thousand years. The Iberian genetic component in these populations is Bronze Age in its origin, not early modern. Whatever Spanish sailors may have survived on Irish shores after 1588, their genetic contribution to the Irish population was negligible compared to what was already there. The actual explanation for the Black Irish is the same explanation that explains everything else about Irish genetics: the Atlantic migration routes that connected Ireland to the Iberian Peninsula over millennia. The people who carried dark hair and dark eye genetics to Ireland did so long before Philip II assembled his fleet. They came on skin boats along the Atlantic coast, in the Bronze Age, in the Neolithic, and possibly earlier still. The Spanish Armada theory, entertaining as it is, attributed to 400 years ago what the DNA places at 4,000 years ago. This does not mean the Armada had no human legacy at all. Historical records document that some Spanish sailors did survive the 1588 wrecks and were sheltered by Irish families, and some of these individuals did settle in Ireland. The genetic trace of this event is simply too small to be reliably detected against the background of the much larger and older Iberian genetic component. A few hundred early modern Spaniards could not measurably alter a genetic profile built over 4,000 years of Atlantic coastal exchange. The modern concept of the Atlantic Ocean as a barrier, a vast emptiness between continents that required heroic technological achievement to cross, reflects our own landlocked thinking far more than the reality of how pre-modern Atlantic coastal people experienced the sea. For Neolithic and Bronze Age communities living along the Atlantic coast of Europe, from Portugal in the south to the Orkney Islands in the north, the sea was not a barrier. It was a highway. A boat capable of coastal navigation could travel the entire length of the European Atlantic seaboard, from the Tagus estuary in Portugal to the northern tip of Scotland, while staying within sight of land or close to it. The Atlantic current patterns and wind systems that prevail along this coast are, in the right seasons, favourable for northward travel. This Atlantic highway is documented in the archaeological record by the distribution of megalithic monuments, the stone tombs, standing stones, and stone circles that appear along the entire Atlantic coast from Portugal through northwestern Spain, up through Brittany and France, across to Britain and Ireland. The similarity between the monument traditions of Western Iberia and those of Ireland, in structural form, in astronomical orientation, in the types of objects deposited inside, is not coincidental. It reflects a shared cultural tradition maintained by communities that were in contact across the sea. The haplogroup R1b, the most common Y chromosome lineage among modern Irish men, present in over 80% of the population, shows its highest global frequencies in Ireland and in two specific regions of the Iberian Peninsula, the Basque Country and Galicia. This distribution is the genetic signature of an Atlantic coastal population that was genetically connected along the entire western seaboard of Europe during the Neolithic and Bronze Age. The R1b lineage does not concentrate in the heartlands of Europe. It concentrates precisely at the margins, at the western Atlantic edge. The ancient seafarers who maintain this connection used boats that have left almost no archaeological trace, hide-covered wooden frames, the predecessors of the traditional Irish curragh, capable of extraordinary voyages in the hands of people who knew the Atlantic coast intimately. Experiment archaeology has demonstrated the practicality of Atlantic coastal voyaging in hide boats. The Atlantic route was not just a migration corridor. It was a trade network that operated for millennia, connecting communities from Portugal to the Orkney Islands in a web of exchange that predates the classical Mediterranean trading world by thousands of years. Of all the genetic connections that link Ireland to the Iberian Peninsula, the most striking involves a people who today occupy a relatively small territory in the borderlands between Spain and France: the Basques. Modern population genetics consistently places the Irish and the Basques among the most genetically similar populations in Europe, despite being separated by the Bay of Biscay and without any documented historical or cultural connection in the conventional sense. The shared genetics are not superficial. They reflect deep common ancestry that goes back thousands of years, to populations that were connected along the Atlantic coast during the Neolithic and Bronze Age periods. The Basque Country and the Galician coast of northwestern Spain are the regions of Iberia closest to Ireland in terms of ocean distance. They are also the regions of Iberia where the haplogroup R1b frequencies most closely match those of Ireland. And they are the regions where ancient DNA from prehistoric sites shows the strongest continuity with the genetic profile of Bronze Age Ireland. The Basque language, Euskara, is famously a language isolate, unrelated to any other known language. The ancient Gaelic language of Ireland and Scotland, while Indo-European and therefore related to Spanish and English, is spoken in regions whose population genetics show exceptional similarity to the Basque population. This is a paradox that ancient DNA helps to partially resolve. The genetic similarity between the Irish and the Basques predates the arrival of Indo-European languages in both regions. The languages diverged while the genetics remained connected, because linguistic change and genetic change operate on different timescales and through different mechanisms. The shared immune genetics between Irish and Basque populations, including similar frequencies of specific human leukocyte antigen variants that affect disease resistance, suggest a long common ancestry whose biological consequences are still visible in the health profiles of both populations today. The genetic similarity between the Irish and the Basques has also been documented in studies of blood group frequencies. The ABO blood group and the RH blood type system show similar distribution patterns in Ireland and the Basque Country, including the notably high frequency of RH negative blood in both populations, that reflect their common ancestry from the same Atlantic Neolithic and Bronze Age founding populations. These are not the kinds of similarities that arise by chance. They are the statistical signature of a shared population history. The genetic connection between Ireland and the Iberian Peninsula is not the only thread linking these two regions of the Atlantic world. Cultural parallels, in religious practice, in music, in art, and in folk tradition, suggest that the genetic connection was accompanied by a flow of ideas and cultural practices that left its own kind of evidence. The festival of Samhain, the Celtic harvest festival celebrated at the end of October that is the direct predecessor of Halloween, has structural parallels in pre-Christian Iberian folk traditions, particularly in the Galician and Asturian regions of northwestern Spain. Both traditions involve the propitiation of ancestral spirits at the boundary between the agricultural year's end and the coming of winter. Both situate this spiritual activity in relation to the landscape, at boundary places, at cave entrances, at water bodies. The structural similarity is not proof of a common origin, but it is consistent with one. The triskelion, a three-armed spiral symbol that appears prominently in the art of Neolithic and Bronze Age Ireland, most famously in the carved stones of the Newgrange Passage tomb, also appears in the prehistoric art of northwestern Iberia. The similarity of these symbols across such a wide geographic range is another marker of the connected Atlantic coastal culture documented in the genetics. Music provides a more contemporary parallel. The bagpipe is today most strongly associated in popular culture with Scotland and Ireland. But the gaita, a bagpipe variant, is also the traditional instrument of Galicia and Asturias in northwestern Spain. Galicia has its own Celtic cultural revival movement, complete with bagpipe bands and Celtic music festivals, because the people of Galicia have long maintained a folk tradition identifying their culture as Celtic. The genetics support this self-identification. The Galicians show significant Atlantic Bronze Age ancestry that connects them to the same population stream that populated Ireland. The roundhouses, circular stone-walled dwellings with conical thatched roofs that characterize Iron Age settlement sites across Ireland, also appear in the archaeological record of Atlantic Iberia, documenting a shared architectural tradition that reflects common ancestry. The Castro culture of Galicia and northern Portugal, the Iron Age hilltop settlement tradition that left the Castros visible across the Galician landscape today, shows remarkable structural similarities to the Iron Age hilltop sites of Western Ireland and Wales. The folk memory of this Atlantic cultural unity, preserved in Irish mythology as the myth of Milesian Spanish origins and in Galician tradition as a Celtic cultural identity, represents the distant echo of a real prehistoric connection that the DNA now confirms. One of the most unexpected sources of evidence for the genetic connection between Ireland and the Iberian Peninsula comes from medical genetics, specifically from the distribution of a condition called hereditary hemochromatosis, sometimes called the Celtic curse. Hemochromatosis is a genetic disorder that causes the body to absorb too much iron from food. Without treatment, the excess iron accumulates in the organs and can eventually cause serious damage to the liver, heart, and pancreas. It is a manageable condition in the modern world, where blood donation or regular phlebotomy can reduce iron levels to normal. Before modern medicine, it was more dangerous. The specific genetic mutation most commonly responsible for hereditary hemochromatosis, a variant in the HFE gene called C282Y, is present at its highest global frequency in Ireland and in the Basque Country and northwestern Iberia. The frequency in Ireland is approximately 10 to 14% of the population carrying at least one copy of the variant, among the highest rates of any disease-associated variant in any European population. The distribution pattern of this variant is precisely the pattern you would expect if the mutation had originated in or spread through a population connected along the Atlantic coast. It follows the same geographic track as the R1b haplogroup, the megalithic monument tradition, and the ancient DNA evidence, concentrated along the Atlantic fringe, highest in Ireland and northwestern Iberia. The variant may have been maintained at high frequencies because it provided some advantage in the specific nutritional and environmental conditions of Atlantic coastal populations. The precise nature of this advantage is debated. Some researchers have proposed that slightly elevated iron levels provided benefit in conditions of dietary iron scarcity or resistance to certain iron-binding bacteria. Whatever the mechanism, the mutation's distribution tells the same story that the ancient DNA tells. These populations share common ancestry, and that ancestry moved along the Atlantic coast. The variant's prevalence in Ireland is so high that Irish genetic testing services specifically screen for it as a routine health measure. The clinical consequence is that Ireland has among the highest rates of diagnosed hemochromatosis of any country in the world, a public health reality that has its origins in the population genetics of the Atlantic Bronze Age. The Irish bog bodies, mummified remains preserved in the peat bogs of Ireland, have provided some of the most vivid physical evidence of Iron Age Irish life, and their ancient DNA has contributed to the genetic picture of Atlantic connections. Old Croghan Man, discovered in County Offaly in 2003, is one of the best preserved Irish bog bodies. He died sometime between 362 and 175 BC, the Iron Age period, and the circumstances of his preservation have allowed an extraordinary level of physical analysis. He was tall, well-nourished, with well-maintained fingernails that showed no heavy manual labor,
consistent with elite status. Isotope analysis of his remains indicated a diet rich in meat and dairy. His ancient DNA, analysed in subsequent studies, shows the genetic profile expected for an Iron Age Irish individual. A combination of the Neolithic Iberian-derived farmer ancestry and the Bronze Age steppe ancestry that defines the modern Irish genetic profile, with the Western Atlantic component more pronounced than the steppe component. The geographic distribution of Atlantic genetics within Ireland itself is not uniform. Populations from Western Ireland, County Mayo, Connemara, the Aran Islands, Kerry, consistently show higher frequencies of the oldest Atlantic genetic components, while Eastern Ireland shows more admixture from later migrations. Viking settlement in the coastal cities, Anglo-Norman presence, and the various other population movements that affected Eastern Ireland more than the more isolated Western communities. This east-west gradient within Ireland is itself a confirmation of the Atlantic origin story. The oldest and deepest Iberian-connected genetics are strongest at the western edge, the margin closest to the Atlantic, the margin farthest from the subsequent migrations that diluted the ancient genetic profile in the east. The genetic evidence from the Irish diaspora, the estimated 70 to 80 million people worldwide with Irish ancestry, concentrated in the United States, Canada, Australia, and the United Kingdom, carries the same Atlantic genetic signal. Every person of Irish descent who has taken a commercial DNA test and found unexpected Iberian ancestry, and millions have, is detecting precisely the Bronze Age and Neolithic connection that the ancient DNA studies have identified. The signal is not a testing artifact. It is real prehistoric ancestry, distributed across the Irish diaspora to every corner of the world. Let's bring together everything the DNA has revealed, because the Irish-Spanish genetic connection is not a single finding, but a convergence of evidence from multiple disciplines and multiple time periods, all pointing in the same direction. The Neolithic farmers who first brought agriculture to Ireland arrived from the south and west, carrying genetics that connected them most strongly to the ancient populations of the Iberian Peninsula and the Mediterranean. The Ballynahati woman's dark eyes and Mediterranean ancestry told that story from 5,200 years ago. The Bronze Age transformation brought new genetics along the same Atlantic coastal route. People whose ancestry combined Iberian Neolithic farmer genetics with the steppe ancestry of the expanding Bronze Age world. The Rathlin Island men carried this combination, and with it the haplogroup R1b that still links modern Irishmen to the Basques and Galicians of northwestern Spain. The distribution of hereditary hemochromatosis follows the same track. The R1b Y chromosome haplogroup follows the same track. The megalithic monument tradition follows the same track. The Celtic music traditions of Western Ireland and Galicia follow the same track. The medieval Irish manuscript tradition that preserved the myth of Milesius of Spain was not inventing a connection to justify political or theological claims. It was preserving, in the only form available to a pre-scientific culture, the folk memory of a real genetic and historical truth, that the ancestors of the Irish people had come, at least in part, from the Iberian Peninsula. The myth was imprecise about the mechanism and wildly imprecise about the timing, but it was pointing at something real. The science of ancient DNA has given that folk memory a precise timeline, a biological mechanism, and a geographic route. The Irish and the Spanish are genetic cousins, separated not by ideology or politics, but by an ocean that their ancestors, for thousands of years, treated as a road. The Atlantic was never a wall. It was always a bridge. And the DNA records of the people on both ends of it prove that the traffic across that bridge was real, sustained, and consequential in ways that are still measurable in living bodies today.
The story ends where the science is most certain and most human, in the DNA of people alive today, who carry within them the record of every migration and every contact that shaped the Atlantic world over thousands of years. The ocean that the ancestors crossed is still there. The genetic record of their crossing still is too.